This video is the tutorial for Blasys, approximate computing using Boolean matrix factorization. The first step is to make sure that all required Python packages and softwares are installed. Then, clone Blasys from GitHub repo. For required softwares, be sure to add them to environment path. Or you can put the directories of executable files of those softwares to config/params.yml over here. Before running Blasys, a test bench has to be created to measure the QOR. Use testbench.py to create test bench of input Verilog file. /n is the optional parameters to specify the number of test vectors. Also, you can define your own arrow metric function to estimate quality of results in utils/metric.py. Inputs to metric function should be simulation result of original circuit and approximate circuit, and return a numerical value as arrow. Here we give two examples of metric function. The first one is Hamming distance HD, and the second one is mean absolute arrow MAE. Generally, Blasys has two modes, non-partitioning and partitioning. For smaller circuits, Blasys is able to generate approximate circuit directly without partitioning. Taking the 4-bit unsigned adder, for example, we specify the input file, test bench, liberty file, output directory, and the metric, which is mean absolute arrow. Use no partitions flag to indicate that approximate without partitioning, and STA flag indicates Blasys will use OpenSTA to estimate power consumption and delay of approximate circuit. After running it, we obtain all approximate design coming from Boolean matrix factorization. However, on the other hand, directly approximating a large circuit is not practical. We use partitioning mode for large input circuit. Take 7-bit unsigned multiplier as an example. There are some other hyperparameters for partitioning mode. Since partitioning mode adopts greedy design space exploration, we need to specify the expected error threshold, which is indicated by #TS. #parallel indicates Blasys is running in parallel to save runtime. #n is the number of partitioning. After running it at each iteration, we explore the possible approximation of each subcircuit in order to obtain an approximate design of top-level circuit. Here is the result coming from approximate multiplier. The area versus arrow scatter plot shows all the approximate designs found by Blasys. The red line is the parental frontier. In result folder, we will have best design at each error threshold, which in our case is 0.2% and 0.5%. Detailed information of those best design is in result file. And we also have the designs of all the parental frontiers in terms of area and power respectively. Taking the area, for example, all the detailed information of those parental frontier designs is in the data file. We also have the command line version of Blasys tools. Simply by executing blasys.py. The first step is to read the liberty file. And then we have to specify the output folder. Now we have to read the input Verilog file and read the test benches we created before. Open parallel mode to save time and specify arrow metric. Here we use mean absolute arrow as an example. open power and delay estimation, and in this case, we partition it into 45 subcircuits. After it gets partitioned, we are ready to do the greedy design space exploration. In the command line mode, we are able to do the iteration one by one by using run_iter command. Now we're about to finish one iteration, and we can check the best approximate design in each iteration by stat command. Here we can see the best design is this for the iteration we just run. We may also specify threshold and let it keep running. Like this. Now Blasys will keep running until all the error threshold is reached. That's all for this tutorial video. Thanks for watching.